The Alps are the most famous and significant mountain range in Europe. They stretch for 745 miles. At their widest, this natural mountain system reaches 161 miles, and the total area covers between 73 and 77,000 square miles. And even the smallest mountain in this system is not only a stunning natural formation, but also an impassable barrier for people. Still, that doesn't really bother Austria, which decided to cut a path nearly 20 miles long under one of the mountain ridges belonging to the Alpine system. For a long time, the biggest tunnel boring machines were at work there, and blasting operations were carried out, during which the mountain lost almost 317 million cubic feet of rock. Of course, let's not forget about the costs. It's over 5 billion euros. And naturally, such a massive sum wasn't spent just to show that Austria can punch its way through the Alps. After the project is completed, the struggling transport system in the south of the country will get a serious upgrade. And the new route through the mountain will link the Baltic and the Adriatic, places that might seem pretty far from Austria. So let's take a closer look at what's going on there. Austria is a scenic land, but at the same time, this scenery brings big logistical challenges. The mountains, the hills, the uneven terrain overall, it's a barrier for every type of transport, except airplanes. One of the biggest logistical problems caused by the terrain came up in the south of the country. Between the two federal states of Styria and Carinthia lies the Caralpa mountain range, which stands as a serious obstacle to getting from one region to the other. And it wouldn't be such a big deal if these states weren't so important for the country. Styria and Carinthia are actually major economic hubs that make a solid contribution to Austria's economy. Styria, often called the industrial heart, is the fourth largest federal state by gross regional product. According to 2023 data, its GRP amounted to about 61.2 billion euros. The region is a major hub for industries like mechanical engineering and metallurgy. On top of that, Styria is a leader in innovation and research, investing heavily in R&D. In turn, Carinthia also plays an important role, combining its natural resources with a growing high-tech sector. In 2023, Carinthia's GDP reached 26.6 billion euros. The region is successfully developing microelectronics and semiconductor technologies while still being a key hub for the tourism industry, which is crucial for its economy. This is how both federal states, complementing each other, create a critically important economic axis in southern Austria. However, getting between the main cities of the regions, Graz in Styria and Klagenfurt in Carinthia, takes about 3 hours by train and around 1.5 hours by car. Let's just say that's not great for the economy, because cargo really needs to move from one point to another as fast as possible. For people who travel from Carinthia to Styria or the other way around, that's also quite a long time. And that's not all. The complicated and slow logistics between Carinthia and Styria also hold back the implementation of EU-wide plans, the Baltic Adriatic corridor connecting the ports of the Baltic Sea with the ports of the Adriatic. As part of this corridor project, European countries are aiming to make railways meet the most modern standards and allow goods to move quickly from one sea to another, because that's exactly how you can improve the economic situation in all the countries along the Baltic Adriatic corridor at once. Here in Austria, the railway is an issue. First of all, it doesn't meet standards, especially in terms of train speeds. Second, this railway seriously increases the time it takes to move goods from one sea to another. As a result, Austria realized that something needed to be done to improve the situation. That's how the Corum Railway project came about, which immediately became a key point both for the Trans-European Transport Network, or TEN-T, and for Austria itself. This railway is an 80-mile route between Styria and Carinthia, more specifically between Graz and Klagenfurt, and it really cuts down the overall travel time from one city to the other. It's fully electrified and designed for a top speed of 155 miles per hour, which meets TEN-T standards. Meanwhile, within the project, more than 100 new bridges and viaducts were built, plus 19 new stations and stops, which they say makes the route one of the most up-to-date in Europe. So it won't be surprising that building the railroad cost a fortune, 11 billion euros. But don't you think that's way too much for a regular railway? It really is a lot, considering that about 5 billion euros of that price goes to the main part of the project, the Corum Tunnel, which is currently being built under the very Caralpa mountain range. This is one of the most ambitious and challenging engineering projects in modern Europe. Two single-track tubes with a total length of 20 miles ranks 7th in the world for length. Naturally, building this complex underground structure meant overcoming major geological and technical hurdles, as well as using the most advanced construction methods. The tunnel construction started with the usual procedures common to any similar project: surveys and geological studies. In fact, the survey work for the Coram Tunnel project can already be considered a fairly large project on its own. For example, a 6-mile exploratory tunnel was drilled, along with 130 additional exploratory wells. These steps allowed geologists to get direct access to the rock and collect samples for lab analysis, which provided accurate info on rock strength, mineral composition, and the presence of fractures. At the same time, hydrogeological studies were conducted to check the rock's permeability and predict possible water inflows into the tunnel. During the prep work, it was found that the rocks weren't uniform. The Koralpa Range contains both gneiss and mica schist. Besides that, there were many fault zones which could make the rock unstable and were a serious safety concern. In short, much to everyone's disappointment, building a tunnel here proved to be no simple task. Thankfully, today there are tunnel boring machines. As part of the project, they played a crucial role in driving through the longest stretches. These machines were essentially moving underground factories, capable of digging out rock, carrying it up, and installing a strong inner tunnel lining all at once. Using them was simply essential to ensure fast and safe work. 2 tunnel boring machines were used to lay 2 parallel tunnel pipes. The enormous machines had a 33-foot cutting head, and their full length, including all supporting systems, stretched several hundred feet. The spinning head, fitted with cutting discs, crushed the rock, and the debris was transported along a conveyor system through the machine to wagons that took it to the surface. Tunnel boring machines were used on the longest and straightest stretches of the tunnel, where the geological conditions were fairly predictable. Using them allowed for fast progress, often topping 66 feet a day in good conditions. However, much to the disappointment of everyone involved in the project, not everything could be done using just the giant moles during construction, so they had to go back to traditional methods. In areas with more complicated geology, like fault zones, the passage was made using drilling and blasting. They set the explosives, detonated them, and then drilled with lighter, more precise equipment compared to tunnel boring machines. Alongside tunneling, they carried out the most important tasks, building the permanent inner lining of the tunnel. A special mechanism positioned prefabricated concrete segments right behind the cutter head, forming rings. These rings, made from several parts, shaped the tunnel's primary lining, giving instant support to the newly excavated section, which was crucial under high ground pressure and unstable rock. Shipping these kinds of segments from a suitable factory far away is just too expensive. Imagine a truck carrying huge elements driving along regular roads. Anyway, the team had to adapt, and as a result, a dedicated site was set up in St. Paul. With 49,000 square feet of space, it could fit all the equipment required for fast, nearly non-stop production. The factory operated 2 shifts, handling more than 18,000 cubic feet of concrete and 25 tons of reinforcing steel every day, which meant an average of 100 concrete segments were produced each day. By 2019, the total count of tunnel elements had reached 42,000. One interesting detail is that the concrete for the segments was made from the slate and gneiss taken out during the tunnel digging. They were crushed and turned into aggregate. This approach was chosen for environmental reasons, since it reduced the need for natural resources like gravel and limited the amount of rock that needed to be transported or dumped. Overall, roughly 39 million cubic feet of concrete came from the excavated rock. Sure, a huge amount of rock went into making the segments, yet, in fact, that's only a tiny fraction. The process of digging out the soil for the Coram Tunnel project was one of the biggest and most challenging parts of the construction. The total amount of material removed came to around 212 million cubic feet, and by some counts, even 304 million cubic feet. The excavation process was carried out using 82 conveyor systems with a total length of 32 miles, which transported the rock straight from the tunnel to the surface, where it was sorted, crushed, and processed at specialized facilities. This allowed for high speed and efficiency, while also greatly reducing the need for truck transport, which was critical for the logistics of a project of this scale. The project practiced a responsible approach towards handling the excavated soil, aiming to minimize the impact on the environment. Instead of just hauling all the material to landfills, a comprehensive plan was developed for its processing and reuse. As a result, most of the soil wasn't considered waste, but rather a valuable resource. About 50% of all the material was processed and used right on site. As we said, part of it was used to make concrete segments, and another part found its use in other areas of construction. For example, the excavated material was used to build railway embankments and protective dams, as well as to create noise barriers and as backfill in 3 different zones. Of course, it's worth mentioning that the mountain route is made as safe as possible. The 2 tunnels that trains will run through are connected every 1,640 feet by cross passages. They serve as the main escape routes in case of an emergency, allowing passengers and staff to move quickly from one tunnel to the other. And if a fire breaks out in one tunnel while people are hiding in the other, they don't have to worry about the flames reaching them. The tunnels are separated by fireproof doors. In the very center of the tunnel, roughly halfway along its length, there's an underground rescue station that acts as a gathering and evacuation point. It has platforms 1,312 feet long in each tunnel and a shelter for people waiting for help. On top of that, it also has fireproof doors and proper ventilation. Naturally, ventilation isn't limited to the central rescue station. A strong system stretches along the entire tunnel with 2 tubes, and if there's an emergency, it turns on automatically to get rid of smoke and supply clean air. Besides that, there's a water mist system that lets you quickly contain and put out a fire, and every 164 feet along the mountain path, there are fire hydrants. They let firefighters on site put out a fire in literally any part of the 2 tunnels. And of course, the trains will also be an example of safety. They'll be equipped with the European Train Control System, which automatically monitors train speed and prevents collisions. What's going on with the Kårholm Tunnel right now? Its full breakthrough was already completed back in 2020, and all the work on the railway tracks wrapped up in 2022. Naturally, trains didn't start running right away. They had to install all the electrical systems, safety systems, check the ventilation, fire safety, and train control. Then they ran test trips and completed all the remaining work. In the end, according to plans, the tunnel will enter regular operation in December 2025. So soon, the region's logistics and even the Baltic Adriatic corridor will be completely transformed. The biggest change will be a drastic cut in travel time between the 2 state capitals, Graz and Klagenfurt. What used to take 3 hours will now take only 45 minutes. This is more than just saving time, it's a total change in daily life. Hundreds of thousands of people in Styria and Carinthia will now be able to commute regularly to work or school, supporting the development of a shared economic area. Cutting travel time will also make weekend getaways or vacations more attractive, encouraging local tourism. Moreover, since one railway also goes to the capital, Vienna, the distance between it and Klagenfurt will be shorter. Before the new railway was built, the trip between these 2 cities could take 3.5 to 4 hours. After the project is finished, the journey will take 45 minutes less. The economy will also transform with shorter travel times between Graz and Klagenfurt. These 2 major centers, which were previously isolated for efficient cargo transport, will turn into a single economic hub. The new urban region, with a population of over 1 million, will offer plenty of opportunities for the labor market. Employees will be able to look for jobs in the neighboring province without having to relocate, and businesses will get access to a larger pool of skilled workers. Besides that, thanks to the new railway line, it'll be possible to ship more goods by train. As a result, the number of companies wanting to do business in one of the 2 federal states, as well as in Austria in general, could grow. You know how hard the European Union and most of its member states work to protect the environment? Well, the new rail line, which lets you get faster from Graz and other cities to Klagenfurt and back, will likely be the reason why tons of companies and everyday people will pick rails and tracks over roads. As has been found in countless studies, trains produce 15 times less carbon dioxide when moving 1 ton of cargo 0.6 miles than road transport. On top of that, it's worth noting that this railway will be completely electric, bringing even greater ecological advantages. Car highways also come with car accidents. A railway route will help cut them down for a simple and already known reason: fewer cars will be driving on the highways. And finally, let's not forget that the Kårholm Railway is not just an upgrade for Austria, but also a key part of the Baltic Adriatic corridor of the Trans-European Transport Network. The impact on corridor countries will be multi-layered. First of all, freight routes from Poland, the Czech Republic, and Slovakia to the ports will get a more competitive overland route. The corridor will cut travel time and be more reliable on schedule, which makes the Baltic and Adriatic ports more accessible to each other and boost their appeal for container traffic. Secondly, some transit cargo might shift in favor of routes through Austria rather than overloaded passes or alternative sea and road routes, which would save time on each shipment and cut logistics costs for exporters and importers. In short, once the Coram Tunnel is up and running and the namesake railway becomes a fully operational route, you could say a new era in logistics for Austria and parts of Europe is about to begin. However, that's not all. Austria is aiming to improve the transport situation even more, and it's actively building another route through the mountain, the Semmering-based tunnel. The goal of building this 17-mile tunnel is to eliminate the bottleneck on the route between Vienna and Graz. Its construction will bypass the old historic line that runs through the Semmering mountain range, known for its steep slopes and numerous curves. As a result, once completed, travel between the country's capital and its southern regions will become much faster and more efficient. It's claimed that the journey time between Vienna and Graz will be cut to 1 hour and 50 minutes. The project was started back in 2012, and it wasn't until 2024 that the tunnel boring was completed. And no, that doesn't mean the work is almost done. As we already mentioned today, tunneling is just part of it. Right now, they're working on lining, laying tracks, installing equipment, and all the rest. The opening is expected only in 2030. That's when Austria will provide the most efficient travel across its territory and greatly improve the movement of goods and people from the Baltic to the Adriatic and back.